Hello and welcome to Trig Transformations. So we're going to hop right into this and start off with a problem. And here we have sketching the following function: y plus 3 equals 6 sine pi over 4 of x plus 2. Give it a moment and see what you can do and how you would sketch the following function. Alright, so going forward, you might think, oh my god, what do I do? Well, the first thing is to try to put it in a form that we're used to, which is, y equals a sine bx plus c, sorry, x minus c, my apologies. Let's put that as a minus c plus d here. Okay, so let's put it in that form. And so I'm going to subtract 3 and just set this up as y equals 6 sine pi over 4, parentheses, x plus 2, in this case minus 3. So note what we already have here is we have our a, we have a b, we have a c, and we have a d here. Talking about, in this case, we have an amplitude, we have a period shift, a phase shift, we have a horizontal shift, and we have a vertical shift. Alright? Remember, we have inside being the domain, and we have outside being the range. So let's take a look at that here, alright, and continue forward by saying if we graph this here, I'm going to make some axes, alright, and say that we do have our parent function, which is sine theta, right, sine of x. So we know that it's supposed to start off at 0, 0 for the origin, right? Now, I want to state, because of the erasing and the grid here, it might be troublesome to redraw some of these over and over. So what I'm going to try and say is, let's say I might draw it here on the side just to go over and say this is my parent function, right? Well, I know that the amplitude 6, right, 6 here is going to make it jump up higher, right? Just going to be some stretched value, stretched graph vertically. I want to look at two things that I think are really important to try and edit, which actually dictate my domain and my range. Okay, because when we're given the graphs before, we're usually given a set of axes, but in this case, we can make our own axes in terms of our steps. We know what are our grid here for, I'll do in red. So like boom, boom, boom. Like, what are these steps? They don't, these increments, they can be whatever we want them to be. And so that really, we have a lot of control of what our graph will look like. Okay? So I'm doing this over on the side just to get an idea of what everything is. So first off, we know that pi over 4 is equal to b, right? And we're looking at the period. We're going to put this into 2 pi divided by the b, which is pi over 4, right? So this comes out to be, in this case, I believe 8, right? So 8 is your period. So 8 units is your period. And I'm going to say here, automatically, if 8 units is my period, I'm going to try to make these red steps along the x-axis 2. All right, I think that's going to be a good value. So let's say 2, 4, 6, 8. And that will be, and so on and so forth, 10, 12. That should give us some good data points for our graph. Okay, so let's keep going. 6 and -8. All right, so we'll do that in just a moment. Let's continue with the horizontal shift, and notice it is +2, and it's inside the function, so it's lying to you. So you might think it is shifting to the right, but it actually is shifting left, right? So in this case here, we're actually going to say when we have this function here, let's see, hang on. Sorry, I was trying to figure out where I wanted to go with this and say that, if this was, on this graph is represented 2, that's actually going to be here moving to the x-axis, let's say 2. Okay? So our graph now starts off at this point, this maximum, and everything shifts over to the left. Okay? So we're going to draw that in just a moment. Okay? So that we understand our shift. Let's handle our y-axis, and our y-axis, our amplitude 6, so we have to go 6 up and 6 down, but we also have a vertical shift of -3. So with that being said, if our axes, our range, here, let me add another one, probably too close, but It's fine, just a sketch. Let's make these grid lines, I don't know, I'm going to say 3 here. I think 3 might work out really nicely. 3, 6, 9, 12. And so this would be -3, -6, -9, -12. So if I do this here, I think this could work out really nicely in terms of trying to understand how things are moving for our graph and our function. So I believe I have everything set up the way I want it to be, so I'm just going to be simple about this and just go, you know what happens when x is 0, right? When x is 0, you're going to have 2 here, right? 2 multiplied by pi over 4, so 2 pi over 4 makes it pi over 2. So you have sine of pi over 2. Sine of pi over 2 at 0, right? So sine of pi over 2 means it is 1, right? Pi over 2, that's 90 degrees. So it's 1 times 6 minus 3. So at 0, you have a value of 3. Let's do this. You know, I'm going to do this in yellow. Let's do that in yellow. Okay, so that's the shift we have here. Now, I might just walk this through the major points, focusing on 2, 4, 6, 8. Because remember our period's 8, so most likely we're going to just check it. But if we plug in 8, we should get back to 3. If we plug in 8, we're going to get 8 plus 2, that's 10. 10 pi over 4, that becomes, we reduce that, 10 pi over 4, that becomes, was it 5 halves? Like 5 pi over 2, is that right? Sine of 5 pi over 2. Well, again, it's pi over 2, right? Pi over 2. And so if we have pi over 2, it's odd. In this case, is that going to be 5 pi over 2? So 5 pi over 2, that gives you which part of the unit circle? Pi over 2, pi over 2, pi over 2, pi. Yep, we're back to here. This is going to make you back at this maximum. So yes, we're going to have a maximum of 3. So let's just check out 4. Looks like it's going to be our minimum. So if we have 4, right, I believe it's going to be 4 plus 2. That's going to be 6. So we have 6 here multiplied by 6 by pi. So you have 6 pi over 4, which reduces to 3 pi over 2. 3 pi over 2 is -1 for sine. So that's -6 minus 3. That becomes -9. So yes, we have a -9 at 4. So I think you're starting to see what's going on here. And you've noticed in between these points, right, in between the max and min, you're going to have a 0, right? But you don't want to put a 0 here because you do have that vertical shift. Because even when this whole thing becomes 0, so you know this is pi, like plug in 2. 2 plus 2, that's 4. 4 pi over 4, that becomes sine of pi. Sine of pi is 0. 0 times 6, that's still 0. You have to still bring it down to the -3. You have to shift it vertically downwards. So that's going to be like this and this. And here is our following function. So this is our sketch for our function. Okay, and you can go on so on and so forth and keep going through, you know, actually trying to draw all this out. And here, where's my -9? Here, and 8 is going to be 3. So on and so forth. You can tell now my scaling is just very, very bad. Because I'm going through the axis over here. I'm going to undo that. Try to... This is where you got to do a little bit better on your sketches. And that turned out horribly. But you get the idea. So this is your function. Y equals sine 6... 6 sine of pi over 4 x of x plus 2 minus 3. All right, on to the next one. So with a slightly different approach for this one, I want you to tell me what the function is of this graph. And, you know, that's a slightly different problem. We have to see, you know, what does it look like and what do we note about it. So I want you to take a moment, see what you can see, infer on how you would try and do this just based on the function itself. And note, hint, look at these lines, look at these grids to try and see what matches with max and mins. All right, I hope you've taken your time to give it a go. So we're going to get right into it and state. Now, I'm going to say there's actually limitless ways of solving this. You can call it a sine function. You can call it a cosine function, actually. It just really depends on how you want to reference it. So in this case here, what I might try and do is say, if I'm looking at this function, right, I'm not sure the scale here. It looks like here this looks like 1, right? So if I'm looking at this point here, this is -1, that it looks like there's a vertical shift down 1, right? If I look at this is a grid line for the halfway point. So I could look at that. That looks like that is a vertical shift down 1, and I might say that that is a vertical shift down 1 would affect probably a cosine function, right? I think that would be good. Or if I think I might want to do that and match this max or min to either this point or this point, figure out which one's best. Because if I match it towards the origin, then I'm dealing with a sine function. If I match it to -1 or 1, I'm looking at a cosine function, right? So let's look at that. All right, I think I'm getting ahead of myself because I want to also, look at the anatomy of it and say, where's our max and where's our min, and find the amplitude and find the period. So if I look at that, the max here looks like it is 1, right? This is pi over 2. Sorry for the terrible colors. 1, right? And your min is pi, and this is, I think, -3, right? -3. So your amplitude, the way you calculate it, is going to be A equals max minus min, the absolute value of it, divided by 2. You're taking the average of the two. So if you take your max, it's going to be 1 minus -3 over 2. You're going to get absolute value of 4 divided by 2. You get 2. So that's your amplitude. So you have an amplitude of 2. So you got to note that in your parent function. And again, I haven't picked that one yet. I'm leaning towards one way yet, but I don't want to jump down that rabbit hole just yet. But I also notice now, what is the period? Well, I look for where it's repleting. And I'm looking at this here, and I see it happen again here. I see a period. I see a period that's equal to pi. So now if I'm going to calculate what pi is, I'm going to go 2 pi over b is equal to the period, right? So this is equal to pi. So I got to figure out, what b is. So 2 pi over b equals pi. Cross multiply, you get 2 pi. Let's do an arrow. 2 pi equals pi times b. You can see that b is simply 2. So now we know b, we know a. Now we're just looking for the vertical and horizontal shift. Okay, if they exist. So in this case, it really again depends on what you're choosing for your function. Because actually, sine and cosine are essentially the same, just one's the horizontal shift of the other. So I typically try to avoid any type of horizontal shift if I can. So I'm probably just going to say this is a vertical shift and base it on a possibly negative cosine function to make it a reciprocal over the x-axis. So since my midline is here, right, and it used to be at the horizontal, the x-axis, right, what I'm going to look at is what is this shift? Well, it's down by 1. So I'm going to say my vertical shift here, the v shift, is equal to -1. And I'm just going to keep it that simple. So if we go to f of x is equal to, now this is where I'm going to say it's a negative amplitude, or so negative a in this case to do a reflection of the x-axis. Now, I will state amplitude can't be negative. Notice that there is an absolute value in your formula. I'm just saying for your equation, your function, I can write -2 and it still causes this function to be the same thing. And this is going to be of cosine, picking cosine because that's where you have a max and min at, or when x is equal to 0. And here we're going to have a b of 2, so 2x here. And then the final part, which is the vertical shift, -1. Okay? So that is how I solve this one. And you could have gotten a different answer, and that's totally fine. So let's just note what that looks like and a different answer. So if you note here that this is a different answer than what we just had, we actually have here a being 2, that the amplitude is still the same, B is also 2, but now there's this horizontal shift, which is pi over 4. And note, when you distribute this B to x and h, you actually get a pi over 2, which is exactly the phase shift between sine and cosine, and still a vertical shift of -1. All right, let's try another problem. So I want you to try to give this one a go on your own, see what you can do and how you would handle it. So I made a little bit of space here so I can work on this. The first thing I would like to do is try to identify some major key points about this, which is, I'm going to start off with the period. So I'm going to look at the max here. I see that over here, and the max over here on the right. So I'm going to start by looking at this and saying, well, let's measure the distance between them. If you notice here, this is over to the left of -2 pi, and it's over to the left of 2 pi. So actually, if I were to shift this over, right, we'd actually have it just on the grid line of 2 pi and -2 pi, which means I'm -2 pi this way and 2 pi this way. The total period then therefore being simply 2 pi plus 2 pi, a total period of 4 pi is your period length. So 4 pi is your period. And if 4 pi is your period, we're going to solve for b. Let's just get right into it. So 2 pi b equals 4 pi. We solve for that, bring b over. So 2 pi equals 4 pi of b. And then you're left with that big line across the screen. Undo. Not sure why that happened. And in this case, you're going to be left with b equaling 1/2. Okay? Now, you might note that basically if you have b as a greater number, that means more oscillations per cycle, right? Per what your unit is unit circle, so 2 pi. But if you have something less than, it's a longer cycle. So this makes sense. Okay? So b is equal to 1/2. So let's look at amplitude, because that's going to be probably fairly easy to calculate. So we have a maximum of 4, and we have a minimum of -2. So therefore, amplitude, we just calculated that before, a is equal to max minus min, 4 minus 2, divided by 2. This is going to be simply 6, right, over 2. You get 3. So your amplitude's 3. So we're almost there. We're practically done. I like the idea of either, let's try to, do we want to try to do sine? I think maybe we'll do sine here to try to help out in case some people are like, yay, I really want to do sine. Yeah, why cosine all the time? So let's try to aim for doing sine in this case. And I'm going to look at trying to see where the middle line is, right? Which it looks like it's here, which looks like it's a vertical shift of 1, right? Because that's the 1 mark. So this is +1 up, it looks like. Yeah, you have halfway up, halfway down. So it looks like that is there. So we have the vertical shift, v shift equals 1. And, last but not least, we have to talk about, okay, what is our horizontal shift? So I'm going to look at here, what is this? Oh, that is a terrible color to bring over. I have to use red again. Bring this over to the y-axis, okay? What's that shift to the y-axis? And to the y-axis, that looks like it's the halfway point between pi over 2, right, and pi. Well, the halfway point would be 3 pi over 4 between those two values, okay, because you have pi over 4 here, another pi over 4 here, and that would be 3 pi over 4. So if you have 3 pi over 4, right, so you have 3, so horizontal shift is equal to 3 pi over 4. The last part is to say, is it negative or is it positive? And we state this with the thought of, what's the movement? That since it's moving left, we're probably going to look at a positive 3 pi over 4. And actually, let's compare that to our formula, and that makes sense because if we're looking at f of x, right, equals a sine bx minus, and this is the part c, right? If we're looking at minus c plus d, if this is a positive, yeah, it will be a negative c in this formula. So let's write this all in. I've filled in all of my information. I'm excited. We're just about done. F of x is equal to a, 3 sine b, which is, in this case, what, 1/2? Yep. X minus 3 pi over 4. That's where that negative comes in. And the final part, plus 1. And that is your function, ladies and gentlemen. So let's look at the answer key. And yes, hallelujah, that is exactly what we got here. You can check that all out over here on your left-hand side. So feel free to check out your own answers through Desmos and, use GeoGebra. There's many tools at your disposal. Hope this video was helpful for you, and looking forward to seeing you all next time. Take care.